welcome everyone to this video. We are going to discuss question number 13, which came in JEE Advanced 2023. So the question is, we have a torsional pendulum which is suspended by two masses uh, in such a way that the point of suspension is beneath the center of mass of the system. So for such a system where this mass is 30 grams, this mass is 20 grams, the corresponding length of the 30 gram mass from the van is going to be some 4 centimeter, and the length of 20 gram mass is going to be 6 centimeter from the van. So we know that the total length of the rod is 10 centimeter. So what we have done is we have uh, divided the length of the rod in the inverse ratio of the masses of the system, that is 30 gram and 20 gram. So the question is that if we rotate the rod in horizontal plane by some small angle theta, it will start doing some small oscillations. Our objective is to find what is the angular frequency of the oscillation. So we are given torsional constant. The thing about torsional constant is that, or the fact which we want to know is that torsional constant represents the torque produced by this uh, sheared, if we can say, sheared wire. There is a torsional shear in the wire, so because of which there is a torque produced, tau is equal to c theta. So now we know that this torque which is produced, that torque is rotating both the masses. Now as it is rotating both the masses, they require some centrifugal force and some linear force as well. So what we can see, if we had a system in which we had to, let's say, rotate a simple uh, object of moment of inertia I, then the angular acceleration of that object would have been some d2 theta by dt2. So that angular acceleration d2 theta by dt2, when multiplied by the moment of inertia of the object, would give us the torque required on the object. So this implies that the angular frequency on that kind of system would have been d2 theta by dt2 is equal to theta. So writing that thing here, this would have been c by I. So the angular frequency would have been square root of ci. So here c is given to us as 1.2 into 10 to the power minus 8 divided by the moment of inertia of the system, which is 30 into. So this value boils down to 180 plus 120 into 10 to the power minus 7 kg meter square. So this is some 1.2 divided by 3 into 10 to the power minus 8 plus 5. So this is 4 and into 10 to the power minus 4. So it have been 2 into 10 to the power minus 2 or 20 into 10 to the power minus 3 radians per second. So n would have been 20. So that is the critical point in the question, that what is the torque provided by such a system. So torque provided was equal to c theta, and it was driving the whole system with this equation, I dt theta by dt2. So that is the point which we have to think about. The physical equation which is driving the system, what that equation is going to look like. So in case of SHM, if there's an angular SHM, so it is some I alpha. Otherwise, there is some m into e. So thank you for joining.